for a very exciting journey to the moon and into this going to development about the Lunar work analysis module. So let me start presenting Yokogawa, a terrestrial industry player to contribute to lunar exploration and industrialization. My name is Satoru. I'm the founder and the executive mentor of the Space Business Development Office of Yokogawa Electric Corporation. I'm also the advisory board member of UNISEC-Global and the CEO of Kurosu Space and Sustainability. So let me briefly introduce Yokogawa. We are not a typical space company, but we are one of the leading process automation companies. So what our process automation company has is mainly three technologies: measurement and control and information technology. Measurement, we have a variety of sensors, and using the sensing of data by the sensors, we control, automate the plant. And these two are the recent examples of our business. The first one is we are the main automation contractor for the largest green hydrogen plant, which will be built in the Rotterdam and the Netherlands, which is the largest in Europe. And we also started the automation project of the first green hydrogen project in Australia. So these are our projects, and we have sensors. So in a nutshell, we supply the brain and nervous system of an industrial plant. So even though I said that we are not a space company, but actually we started the space business very early, back in 1961, when we supplied the ionosphere sensors to the former JAXA organization, University of Tokyo. We supplied about 30 sensors, which was launched by Kappa 8 rocket from various parts of Japan. And NASA became interested in that, and we supplied several sensors to NASA too. And the first one was mounted in this right-tailed rocket and launched from their Wallops Island. So it was very a nice start, but frankly speaking, we did this kind of a space project as just a project by project basis, no continuity and no, knowledge succession. So just in July 2021, I created the first dedicated space organization to combine all the technology and focusing on the space customer space project for the Space Business Development Office, the name of the organization. And these are the examples that we are doing now. First one, the more exploration. I'll come back to it later. And we supply the one payload together with Children Corporation for the life science experiment in the ISS. And we have been doing several projects about Earth observation using data from satellite. And this example is we supply the kind of data analysis services for the customer of the pulp and paper in Latin America to grow the forest efficiently or to absorb carbon dioxide more efficiently. And we have been developing one special fiber optic sensor with JAXA, which can have the multiple point of temperature and vibration data gathering points by just one fiber optic cable. And then another one is that we have been working with JAXA and other academia to create a very special way to make a semiconductor with a small quantity. So let me start talking about the moon, starting from why Yokogawa is going to the moon. First point is we believe this is the closest potential industrial location to the Earth in space. So there's the land, of course, on the moon, and we can build a large infrastructure there. We can create an industry. So if this is realized, we can utilize our strengths on the terrestrial industry, measurement, control, and information technology to support the automated plant and automate all the infrastructure. This is the first point. Second point, the emerging lunar industries. Of course, everybody knows that the water is found on the moon. So these make the sustainable scale of sustainable industrial development possible. And there are actual projects to support this kind of movement, like Artemis, and the Japanese government is heavily supporting this movement to the moon. And most importantly today is that there are many, even more than 50 Japanese private companies very keen to work together to create an industry on the moon. So typical the organization in Japan is called the Lunar Industry Vision Council, which today's presenter, many of the presenters are now members, and we are working very closely together. And also, lastly, we believe the technology and solution created for the extreme environmental moon can be utilized to solve the problem on the Earth too, like to achieve SDGs. So it's the busy slide, but this is just the history of our development of the moon. And as I said, that we joined the Lunar Industry Vision Council. Actually, we were a founding member in 2021 and started the joint work under the government, Ministry of Economy, Trade and Industry, to design and create industries, hydrogen-based energy related technology on the moon. And as Urata-san said, in January 2022, we started a collaboration with the Chuba Corporation, iSpace, and professor from University of Tokyo and Ibaraki University to create the solution for the lunar water analysis and to enhance our relationship with the iSpace and support the activity iSpace. We became a Hacktower, the supporting company. And recently, we had another joint work with an important partner, JC Corporation, for the lunar plant control system that will support ultra-remote communication. I'll come back to you later. And then 2 months ago, we also joined the Euro2Moon, European initiative dedicated to sustainable lunar and space exploration. So here and after, there are many actual active activities in Japan and Europe, etc. So now it's really the time to go to the moon. So this is a picture of the hydrogen-based supply chain on the moon. The water is there. So after the exploration of water, we can divide it into the hydrogen and oxygen. And hydrogen can be used for the energy or propellant, and oxygen can be used for the human habitation. So these orange boxes are Yokogawa technology. Today, I will introduce analyzer for water measurement and also the control system. So these are the picture of the Yokogawa portfolio. So I don't explain the detail, but we have a bunch of sensors and control system and some life science equipment. This is on the ISS and so on. And we have been converting these to the space use one by one. And I'll explain this, the water analysis module using this technology of Institute Gas Analyzer. So here is our core technology. And these are the, this product is called TDLS, tunable diode laser spectrometer. And it can measure the very small contents of gas or moisture. And we have supplied more than, I think, 3,000 units to the terrestrial industries. So this is industry use, and our sensors used for the very extreme environment, like Arctic or deep seas. And so this kind of a robust solution can be a good weapon to measure the gas or the moisture on the moon. So there are lots of experience to measure the gas, like in addition to the water, moisture, O2, CO, CO2, methane, and ammonia, H2S, and HCl, you name that. So this means that not only the water analysis, we can use this kind of analyzer for other purposes like Eclipse or support system. So we supplied this analyzer, and Chuba Corporation will integrate this as a water analysis module. And these are the development activities fully supported by iSpace and also the expert from the Tokyo and Ibaraki University, as Iwata-san introduced. So this is a heavy duty sensor. So we are now making a compact who are mounted on either the lander in this picture or in the second phase rover type. So we already have a prototype demo module, which was created by Chiyoda Corporation. And here is the sound of the artificial Legolis and the drills here, and get the Legolis out of the drill and vaporize that, and then go to the our analyzer to sense the very small moisture in the Legolis. So this is the first example, the water analysis module using our laser technology. And another one is we are very closely working with JGC Corporation for the lunar plant control under the very ultra remote communication. So we will automate the plant. Automation is a strength. However, to start up a plant, we need to tune up first. And this means human interaction. But in case of a moon, so we cannot depend on the astronauts, for example. They are very expensive and time is very limited. So in any case, we need to support this startup, a part of our control, at least during the startup period. So we need to solve the latency of, let's say, 5 to 10 second latencies. So we created the test bench to simulate this delay using our sensors and also the control system. And this simulation can create a kind of a challenging environment of latency. And now we are working together with the JGC Corporation how to solve this issue using, for example, digital twin simulation technology. So this demo machine was shown in the third International Space Industry Exhibition in this February. So this machine with the rotary remote control and also water analysis module was demonstrated in the same place. So Yokogawa contributed to create lunar industries, leveraging our strengths in measurement, control, and information technologies, and utilize lunar-borne technologies and solutions to solve terrestrial issues too. Thank you very much for your attention. Thank you.